We've discovered a previously unrecognized mechanism for the transmission of pathogens from the environment to their potential hosts. What this means is we have found a new transmission vehicle for diseases like cholera. In certain parts of the world, cholera is a problem because of contaminated drinking water that people have to consume, either because of poor sanitation or because of natural disasters that damaged the water delivery and purification systems. So my group works on looking at how bacteria interact with higher organisms in the environment. One of the higher organisms that they interact with are protozoa. Protozoa are single-celled organisms that feed on bacteria. When protozoa feed on bacteria, they normally engulf bacteria and they're stored in food vacuoles where they're digested. And we have noticed when we were studying this interaction that in some cases certain pathogenic bacteria like the cholera bacteria, instead of the cells being digested, basically get released in the fecal pellets. We call them expelled food vacuoles or EFVs. They contain live bacteria that are expelled back to the environment. And interestingly, the bacteria inside of those expelled food vacuoles or EFVs are resistant to a variety of stresses. In the case of the cholera bacteria, we've shown that it's more resistant to antimicrobials, to starvation and pH stress. And most importantly, we've shown that using a mouse model of infection, that the cholera-containing EFVs are able to colonize almost 10 times more effectively the intestine than free-living bacteria. So this indicates that when people consume water, either in contaminated drinking water in areas where cholera is endemic, or potentially swallowing recreational waters where these bacteria and protozoa occur, then humans are at a higher risk of getting infections of cholera and potentially other organisms that are packaged in EFVs. So the next aim for us then is to develop methods for detection of these EFVs where they're going to be a problem for infection of humans, like recreational water bodies or the testing of drinking water. And in the case of other pathogens such as Legionella, they could potentially be occurring in cooling towers, for example, or other areas where Legionella is a problem. So if we can figure out ways to detect these vacuoles, then we can prevent their transmission to potential hosts. And if we can prevent the expulsion of EFVs, potentially disrupt this process, then we can potentially reduce the incidence of EFVs in the environment, where they're probably responsible for many more infections than we're aware of.